two limits. L'Hopital's will not be effective on your next exam. All right. So I guess the tan 7 I'm going to write as sine 7 on cos 7 again, right? That kind of game.
Go.
You okay?
Me?
Yeah, your eye. You all right?
My eye.
Yeah, your right eye.
What's wrong with my right eye?
That's your left, by the way. Your finger's in it. That's the problem. No.
What's wrong with my right eye?
It just looked a little weird for a second.
Thanks.
You said it. Okay, fine.
I don't know what's wrong with it now.
Okay, nothing.
Go blind.
Sorry. I just cursed you accidentally. I'm sorry. I did not mean to.
Okay.
I think you'll be fine.
He's got magic. He used his magic on you.
It's right like that at first.
That's what I was going to say.
So when we had the tan 5x previously, we multiplied by 5 on 5. And in this case, the sine 7x has no x underneath it. That's the main problem right now. There's no x underneath it. What I'd really like to have is a 7x underneath it, and it does not have one, right? The sine 7x has no 7x underneath it. And that's what I would need to interpret it in terms of that limit over there, right? So I guess I'll multiply by 7x. Over 7x, is that what you said?
Yeah, 1 over 7x.
1 over 7x?
Yeah.
And I'll have to do another 1 over 7x, right? It's what Raj was saying a second ago. I've got to make sure I don't change the value.
Yeah.
So I have to introduce a 7x down here for this one. But once I put one down here, I've got to put another one, and I have two choices. I can either put it up here, which doesn't do me any good whatsoever, or I can put it underneath this one, which does do me good, because the x underneath this one anyway.
Can I just flip the reciprocal? Or the sine of x?
For the sine of x, this one?
Yeah.
Here?
Yeah, so it would be easier, so you would have 7 on the bottom and the top.
Since we don't have a 7 on both on the top? You say,
I said then you can get a 7 on both the top, bottom and top. See them?
okay, so I'm going to put it in red here for danger. I'm not sure yet. Hold on a second. So limit as x approaches 0. Put the sine x next to this. Okay? Sine 7x. Sine x. Cos 7x. Okay? So put a 7x underneath this one and a 7x underneath this one.
Yeah. Actually,
Let's do it. No, let's do it. It's perfect. Then as x goes to 0, sine, you're now introducing a 7x underneath the numerator, so it appears like this. But once you do that, you have to put it underneath the other one as well. So you have sine x cos x on 7x. Does that make sense? You have not changed the value of what's inside the limit, right? You've just chosen a particular place to put the 7x. Certainly, this is, you can read this, these two things are the same, right? These two things are the same. If you were to take the reciprocal of this and multiply through, sin x's would cancel, you know, sin x cos x, sorry, cos 7x, on the bottom, right?
Oh wait, so you, hold on one second. You multiplied by 1/7?
I multiplied the top by Serrati's suggestion, 1 over 7x.
Okay.
Once I do that to the top, I must do the same thing to the bottom. So I've multiplied the top by 1 over 7x, and multiply the bottom by 1 over 7x.
Okay.
Okay? And I've written this way for a reason.
so you have a finite value at the top, right?
That's correct. It's going to become a 1, right?
Wait, I have
Yeah.
a question.
Yeah.
How did you get the cos 7x down there?
Down here.
Yeah.
Yeah,
Same thing as before. Just however you want to look at it.
Okay.
You can always just push this thing down, and these two will go on the same line.
Never mind, I thought it was some other way. I get it.
So now, sin x on 7x is not the way that looks, right? Top is fine. We've got the top taken care of. Agreed? Top's heading towards 1. The problem now is the sin x on the 7x. This 7 is not doing anything for that limit, right? Because this has an x in it, so all it needs is an x below it. We had to put the 7 here because we put the 7 here, which we did need, but it's not really affecting the sin x on x limit, all right? So conceptually, you need to take it out.
So you're going to pull out the 1/7.
Pull out the 1/7. But what's a 1/7 down here, really? It's really a 7 up here, right? So I could just pull out a 7.
Answer stuff you're saying?
Here's that. Like that. You have sine 7x. You gotta be good with your algebra for these kind of problems. You have sine x. I'm going to put the x with the sine x, like this, times cos 7x. Does that make any sense?
No.
Wait,
Good.
put on pause.
What, really?
Yeah.
Yeah.
Okay. Let's think about this 7 for a second. It's bothering me. Why? Because I want this to look like sine x on x down here, so it looks like this expression. I want to see a sine x on x. So this 7 is in my way, so I want to get rid of it. This 7 down here is really a regular 7 up here. Okay? Because if you flipped and if you took the reciprocal and multiplied, you'd have a 7 up here, right? So I'm moving that 7 to the outside of the whole thing. Any constant you can move outside a limit. Okay? So it goes out there. So this 7 is now not bothering us. And I'm choosing to associate the x down here with just the sine x part, because that is what this limit needs to look like. Okay?
Wouldn't there be 2 7s to the outside? If you were going to bring that sine 7x to the outside also?
This one?
Yeah.
No, I want that one there. Because that's 7x here, I need 7x down here.
Oh, you're not going to pull it, you're not going to pull the 7 out?
No, I want it there. I want it to be inside the limit, so it looks like that. So it looks like argument over same thing. You need the same thing.
That equals 7 or that equals 1?
1. This part alone equals 1. When argument and value below argument are the same thing,
Oh, we have the 7 to the outside, that's the reason that would. Oh, okay, I see.
this cosine 7x poses no problem for anything. It's going to go to 1, right? So now all 3 pieces of this, the upper part is going to 1. This bottom part here, the sine x on x, is going to 1. And this is going to 1. Right? All its little own. Right? It's just cos 7x. Because x goes to 0, it gets close to 1. So now we know the answer is 7 times 1 over 1 times 1, which is 7. Okay? Again, these are not obvious. It takes a lot of algebraic chicanery and practice.
I realize that all the numbers that we've done, the numerator side, with the number inside the x function, ends up being
That's right.
you know why that is? Is that just a hash?
No, that's the way it is.
So you can't get a possibly wrong with all that.
No, you can still goof it up. I'm taking the simplest ones. Taking the simplest ones. Alright, everybody's okay with these now? At least as you're going to be for the moment. So you practice them some more. They're not straightforward. Again, I don't think they are. Take some practice. Alright, let's do some derivatives of trig functions then. What the hell solution to this?
One question.
Yeah.
The lim sine x over x
Yeah.
equal 1.
Yeah.
So can you say lim x over sine x equal 1? Can you say that? The x over sine x equal 1, because the quotient
Yeah,
can
sure. Alright, derivatives. Again, I'm going to give you 2 fundamental derivatives, and we'll figure out the rest. The derivative operator, d dx, applied to the sine function. So this says, what is the slope of the sine function? The slope of the sine function is the cosine function.